Hello my dear students. In this video we are going to discuss the project management techniques. As we know that there are certain situations in which the decision maker has to select the best optimal solution. Generally, the optimal solutions are selected on the basis of several mathematical or graphical techniques. In today's lecture, we are going to discuss two such techniques that are used to optimize a project. We would be discussing about two well-known techniques of project management. These are known as project evaluation and review technique and critical path method. These techniques are very useful in planning and controlling of projects of larger size. Before moving ahead, we should understand the meaning of project. A project is an interrelated set of activities that has a definite starting and ending point, and that results in a unique product or service. In other words, we can say that a project consists of large number of activities that are basically interrelated and can be arranged in a logical order. Being a set of large number of activities makes a project very complex to manage. For example, construction of a residential complex, construction of a shopping center, construction of any ship or aircraft, research project for the development of a new drug, space projects or space missions, and mega installations are some examples of projects which are larger in size and thus very complex to manage. Further, project management can be defined as a combination of scientific techniques that are used for the purpose of planning, implementing, monitoring, and controlling the various activities or aspects of a project. That can include the time, money, materials, manpower, and other resources. The objectives of project management may vary from profit maximization to cost minimization, or the minimization of the total time that is taken to complete a project. So to manage the complex and mega projects, there are several mathematical techniques or analytical techniques that are used or can be used in different situations. In this lecture, we would discuss about some network analysis techniques that are used for the purpose of management of a project. A network basically is a graphic representation or depiction of various activities that are conducted and the combination of events that occurred during the completion of a project. So basically, a network is a graphic representation of several activities or events that might take place during the completion of a project in hand. Generally, there are two types of network analysis techniques that are very well known and are used for the purpose of project management. These are, the first one is project evaluation and review technique, that is known as PERT, and second one is the critical path method, that is CPM technique. So these are two very popular techniques that are used for the purpose of management of a project. What is the use of PERT and CPM in project management? First one is the use in planning. PERT and CPM are very useful techniques for the purpose of planning about the overall layout of the project, estimation of time consumed by different activities and by the overall project or whole project, estimation of requirement of resources for all the activities, setting the time and sequence of performing various jobs that are required or that are required to complete the project. So the first and basic purpose of using PERT and CPM is to help the management in planning about certain and key aspects of the project that may vary from determining or laying the overall layout of the project, estimating the time, estimation of the requirement of different resources for different activities, setting the time and sequence of different activities. So these activities are very crucial for the successful completion of any project. The second use of PERT and CPM is about the controlling. At planning stage, with the help of PERT and CPM, the management sets different standards or goals for different activities and for the project in whole. So to check if the goals that are predetermined or set by the management are achieved or not, we can use PERT and CPM techniques. So to match the actual performance with the set standards, and on the basis of the results, the management can act accordingly. So it is very common to find the gaps between the actual performance and the set standards. So to minimize that gap and primarily the negative gaps or negative deviations, the management can use the PERT and CPM techniques. So what are those situations in which PERT and CPM network analysis techniques are suitable or can be utilized for the purpose of management? So basically any situation in which the activities or jobs or different tasks performed to complete any project are well defined. So first of all, the different activities that are involved in a particular project should be well defined and clearly identified. Only in that case we can use PERT or CPM network analysis techniques for the purpose of efficient management. Second condition is that the starting and endings of such activities or tasks are not dependent on each other. It means all activities have their own starting and ending points, and their starting and ending points are not dependent on any other activity or any other task. The third condition is that these activities should be ordered in any logical or technological sequence in such manner that certain activities can start only after completion of their respective preceding activity or activities. So there is a precedence relationship between the activities that are performed to complete a project. So basically the activities or jobs should be clearly identified and well defined, and they should have their own starting and ending point that are not dependent on each other, and further the activities can be ordered in any logical or technological sequence or order in such a manner that any activity can start only after completion of all the activities that are before or that comes before this activity. Now we would understand the applicability of PERT and CPM techniques. In what situations we can apply CPM technique, and in what scenario or situations we can apply PERT technique. Applicability of CPM. So the situations in which the completion time of whole project is certain and assumed to be known, in that case we can use critical path method technique for the purpose of project management. Second, the completion times of different activities are certain and again assumed to be known to the management or the decision maker. Third, amount of resources that are required to complete different activities and to complete the whole project are assumed to be known to the decision maker or to the management. The fourth condition is that being deterministic in nature, and on the basis of 3 points, first 3 points, that is first, second and third point, we can understand that Under conditions of certainty, we can apply critical path method. So this technique becomes deterministic in nature. So on the basis of these features or conditions, CPM is found suitable for construction projects that are repetitive in nature, and on the basis of the past experiences and historical data, we can find we can assume the completion time, or the completion time of different activities, or completion time of the whole project, and the amount of resources required for completion of different activities can be assumed with certainty. So under conditions of certainty, we can apply critical path method technique. Further, what would be the situations in which the PERT technique can be applied? So the first such condition is that the completion time of whole project is not certain. Unlike the CPM method, in these situations, the completion time of whole project is not certain and assumed to be unknown to the decision maker. Second, the completion times of different activities are also not certain and not known to the decision maker. And again, the amount of resources required to complete different activities is also not known, or not assumed, or assumed to be not known to the decision makers. So unlike the CPM method, PERT technique is probabilistic in nature. So it is found suitable for research and development projects that don't have any historical data, or in which it is not possible to know the completion time of whole project and of different activities, and it is also not possible to know the amount of resources required to complete different activities that are required to be performed for the completion of the project. So what would be the procedure or standard procedure for applying these techniques? As these two techniques are very similar in terms of concepts, method and methodology used, or terminologies used, these two techniques are very similar in nature. The only difference is about the situations in which they can be applied. CPM method can be applied in conditions with certainty of different aspects of the project, and in conditions of uncertainty, the PERT technique can be applied. So what would be the procedure of applying these techniques? So in step 1, we need to portray or draw a given project in a graphical form, or we need to construct a network of activities while keeping in view their logical sequence or their logical precedence. In step 2, we need to analyze the network by determining different aspects of the network, that is the earliest start, earliest finish, latest start of an activity, or latest finish of the activities that are performed in a project. In third step, we would determine the critical path of the project that required the maximum attention of the managers or the project managers. In fourth step, we would calculate the different floats in the network, like interfering float, free float, or independent float. And in last step, based on the time cost and trade-off analysis, we would determine the timing of starting of the project or of different activities and sequence of the activities and the project. So in this manner, or in this we would follow this procedure to apply PERT and CPM techniques. So before moving ahead, we need to understand some basic concepts that are related with network construction. That is the step 1 to apply PERT or CPM technique. So the first such basic concept is activity. Activity may be defined as any task or job that makes a feasible part or a visible part of a project and consumes significant amount of resources like time and money. Further, it has a definable starting and ending point which makes it a separate and recognizable part of the project. Basically, activities in a network are shown in form of arrows or arcs. Like in this diagram, we have different activities that are involved in a particular project. Activity A is decided with the help of a row. Like activity is defined by this row, this arrow. Similarly, B activity is shown by this arrow, that is between point 2 and 3. In a similar manner, activity C is depicted with the help of the arrow between point 2 and 4. So in this way, we represent an activity in a network with the help of an arrow. The second such basic concept is the nodes or events. Basically, nodes or events are represented in form of circles in network diagram, and the nodes and events denote the beginning and ending of activities. Like in this diagram, is the node 1 that denotes the starting of activity A, and there is the second node 2, that denotes the ending of activity A, and further it denotes the starting of activity B and starting of activity C. So basically, nodes or events in a network shows the starting point or ending point of different activities. So if we talk about activity A, in this case 1 would be the starting point of activity A and 2 would be the ending point of the activity A. 1 would be known as the tail event, as it denotes the tail of an arrow, and 2 would be known as the head event, as it represents the head of an arrow. So 1 would be as tail event and 2 would be known as the head event. And in case of B, if you talk about the activity B, 2 would be the tail event and 3 would be the head event. Third basic concept is precedence relationship. It means the predecessors of a particular activity are those activities that must be completed to start this one. So that means to start any activity, all the preceding activity of that activity must be completed. Only after that a particular activity can be started. So the precedence can be of two types. The first one is immediate predecessor. As the name is suggesting, these activities must be completed immediately before starting any particular activity. That's why these are known as immediate predecessor. And second, the distant predecessor. Basically, these are the predecessors of a particular activity, and these are not the immediate predecessors. For example, if we talk about activity D, for activity D, the immediate predecessor or preceding activity would be B, because it be completed immediately before starting of activity D. But activity A is also the predecessor of activity D, as it has completed before starting of activity D, but not the immediate one. It is the distant one, because it has completed even before of starting activity B. So in case of D, activity B would be known as the immediate predecessor, and activity A would be the distant predecessor. Similarly, if you talk about activity F, the immediate predecessor would be activity A, E, and the distant predecessor would be activity C and activity A. Similarly, for activity H, the immediate predecessor activity would be G, and rest of them would be the distant predecessors. So we should keep in mind this concept while drawing any network. We should identify the which activity is the immediate predecessor and which one is the distant predecessor, because with that clarity, only with that clarity we can draw a network of the activities. So these are some basic concepts that we should keep in mind while drawing a network for a project. Now we would discuss some rules of drawing a network or constructing a network for a particular project. The first rule is that events are identified by numbers. Events are identified by numbers. As you can see in this network, there are red circles which are denoted or identified with a specific number. Like the first event, generally we start from the left hand side and we assign first event a numerical value equal to 1. Similarly, second event is denoted as 2 and third event is denoted as 3. So basically we start from the left side and we assign numbers to events in an ascending order. Like you can see, first one is denoted as 1, second as 2, third is 3, similarly fourth one as 4, fifth one as 5. So in a similar manner we have identified or denoted all the events with particular numbers that are in a ascending sequence. The second rule of drawing a network is that activities of a network are identified by numbers of their starting and terminating events. Like in this network, activity A would be identified as activity 1, 2, where 1 is the starting point of activity A and 2 is the ending or terminating point of activity B. Similarly, activity D would be identified as 3, 6, where 3 denotes the starting point of activity D and 6 denotes the ending or terminating point of activity D. In a similar manner, activity H would be identified as 7, 8, activity 7, 8, where 7 denotes the starting point and 8 denotes the ending point. So activities of a network are identified by numbers of their starting and terminating events. So these are some basic rules that we should keep in mind while drawing a network for any particular project. The third rule of drawing a network is that there should be only one starting and one ending node of the project network. As you can see, in this network there is only one starting node, that is 1, and there is only one ending node, that is 8. So we should keep in mind that there cannot be more than one starting or more than one ending node of the project network. The next rule is that each defined activity of the project is represented by only one arrow. That means an activity can be represented only once in the project or in the project network and not more than that. For example, activity A is represented in starting of the project as 1, 2. 1 is the starting point of activity A and 2 is the terminating point for activity A. Except that we have shown activity A nowhere in the network. So activity A is represented only once in this network, and similarly other activities are also represented only once. They cannot be represented more than once in any particular network. So activity B is also represented only once. Similarly, activity D, activity E, activity F or activity G, all of them are represented only once. So it is the most fundamental rule of drawing a network that all the activities in a particular network should be shown only once and not more than that. So here comes the most fundamental rule of drawing a network, that is that all the preceding activities of any activity must be completed before starting that particular activity. Like if we want to start the activity B, then activity A must be completed because activity A is the preceding activity of activity B. So we cannot start activity B without completing the activity A. In a similar manner, to start activity D, that is from node 3 or event 3 to event 6, we should complete activity B and activity A. So without completing activity B or activity A, we cannot start activity D. In a similar manner, if you want to start the activity F, it can only be started after completion of activity E, activity C and activity A. So all the preceding activities must be completed to start a new activity. In a similar manner, to start activity H, we should complete all the preceding activities of this network from A to G. And on that basis, we can say that the network should be developed or constructed on the basis of logical sequence of the activities. So we should follow the logical sequence and this rule that preceding activities of a particular activity must be completed to start this activity. Next rule is that the length of the arrows representing various activities have no significance or are of no use. Like you can see here, activity D is represented by a longer arrow in comparison of activity F, which is represented by a shorter or a small arrow. So the length of the arrow has nothing to do with the significance of the activity or the time taken by any particular activity. So the length of the arrows are of no use or have no significance as far as the analysis of the network is concerned. So you can take any length of the arrows while drawing a network. The next rule is that the head of the arrow represents the point of completing of an activity, while the tail depicts the starting point of that particular activity. As we have discussed earlier, for example, in case of A, event 1 would represent the starting point of the activity and it would be known as the tail event, and event 2 would depict this ending point or completion point of activity A and would be known as head event. And in case of E, 4 would be the starting point or tail event and 5 would be the ending point or head event. So the head of the arrow represents the point of completion of any particular activity, and the tail of that arrow depicts the starting point of the activity. So here comes the two basic terms that are generally used while drawing a network. When more than one activity end or terminate at an event, then that event would be called as merge event. Like in this diagram, look at event 6. As we can see that activity D is ending at event 6 and activity F is also ending at event 6. So there are more than one activity or activities that are ending at a particular event. So event 6 would be known as merge event, as there are two activities, that is D and F, are merging at this point or terminating at this point, and it would be known as merge event. While the event which depicts the initiation or starting of more than one activity would be known as burst event. Like in this diagram we can see the node 2 or event 2 depicts the starting of two activities, that is activity B and activity C. So event 2 would be known as the burst event, because more than one activities are emanating from this particular event. So there are two fundamental terms, merge event and burst event. So merge event would depict the end or termination of more than one activity, and burst event would show or depict the starting or initiation of more than one activity. The final rule that is of great importance while drawing a network is that there cannot be two parallel activities between similar starting and ending events. That means if there are two events like 1 and 3 in this particular network, then there cannot be two activities between these 2 points which have the same starting point or starting event and same or similar ending point. If there are such activities, if there are such activities, then dummy activities are required to draw the network. So here comes the concept of dummy activity. Dummy activities are those activities which are not the real activity or not represents any real part of a project, but we have to show them in a particular network. And in what situations we need to draw the dummy activity? In situations in which, or unusual circumstances in which, there are two or more activities that have same starting and ending events. So there can be two such situations. The first one is that when two or more activities start and terminate at same event, that is known as identity dummy. So in the first graph, as we can see here, there are two activities, activity C and activity B, which are happening or taking place between this event and this event. So in that case, what we need to do, we have to introduce a dummy activity. And how we would do that, like we can do in this way. We would represent the activity C through another route by including a dummy activity. Here the activity B would be represented directly between node A and node D, or you can give any number to this event. So suppose it is 1 and it is 2. So between event 1 and 2 there are two activities, activity B and activity C. As we cannot represent them, so we need to draw the dummy activity. So first what we need to do, simply draw any of the activity between two given events. That is, we have drawn activity B between the given events. The second activity would be drawn like this. Start from the starting node, the activity, second activity, and introduce a new event, that is number 3. And from this event, draw a dummy activity between event 3 and event 2. So in this way we can introduce the dummy activity. So by this way, now we can see that activity B and activity C has not same do not have the same starting or ending events, because we have introduced the dummy activity. The second situation in which we need to introduce the dummy activity is that when two or more activities share the same precedence activity but not all the precedents are shared. It means if two activities have some common predecessors, or all or have some similar predecessors, but not all of the predecessors are same. We can understand with the help of this second diagram. So let's have a look on activity or event activity C and activity D. The predecessor of activity C is activity A, like you can see in this diagram, and the predecessors of activity D includes activity B and activity A also, as there is a common predecessor, that is A. Activity D and activity C both have a common predecessor, that is activity A, but in addition to A, activity D also have an additional predecessor, that is activity B. So it shows the situation in which some activities share the some precedence activities, but not all of them. So to handle such situations, we need to draw the dummy activity in this manner. By drawing a dotted arrow, we can see, or by drawing a dashed arrow, we can see that there is a dummy activity between event 4 and 3. That shows that activity D has two predecessors. One is activity B and another one is activity A. So in this way we can complete our network for a particular project. So these were some basic rules that should be kept in mind while drawing a network to manage a particular project in an efficient manner. So these were some basic concepts, or the introduction of the PERT and CPM techniques. In next videos of this lecture series, we would discuss how to find the earliest start, or how to calculate the earliest start, latest start, earliest finish, or latest finish for the activities in a particular network. Thank you.